Welcome to Master Simple Physics. In order to do physics well, you must understand the meaning of vectors and scalar. Today's topic, we talk about distance versus displacement. In order for you to understand, we use a simple concept of length from A to B. If we do not want to consider the directions from A to B, use the ruler to measure the path from A to B. If we consider the direction from A to B, it means that it is a straight line from point A to point B. Diagram 1 is called scalar. Diagram 2 is called vectors. Now, what is the meaning of scalar and vectors? Look at the definitions. A scalar is a quantity which has magnitudes or values but no direction. Vectors is a quantity which has direction as well as magnitude, or we call values. Give an example of these diagrams. Mary walks along the circular walk path. Question 1. If Mary walks from A to B along the circle, find the length in terms of scalar. It means that it is equal to the length of peripheral of circle A to B, which is equal to 4 pi r divided by 4. Whereas for vectors is equal to the length of a straight line from A to B. Question 2. Mary walks from A to B then C along the circle and back A again. So find the length in terms of scalar and vectors. Can you get answer? So in terms of scalar, it means the peripheral length of a half circle, 4 pi r divided by 2. If in terms of vector, it's over point A back to point A, length equal to 0. Distance is a scalar length and vector length is displacement. So look at the definition of distance. Distance is the length of travel between 2 points without considering its directions. Distance is a scalar quantity. Displacement is the shortest length of travel between 2 points with consideration of a direction. Displacement is a vector's quantity. Now, you look at the examples. In these diagrams, a red ball hit against the upper wall and rebounds. Find the total distance and displacement. In terms of scalar, we do not need to consider the direction, so we can add the value directly, 4 meters plus 2 meters. But in terms of displacement, we need to consider direction. Hence, we have defined what is called positive or negative. We always need to set the reference point. So upwards we call positive, downwards we call negative. So the displacement will be equal to plus 4 minus 2 equal to 2 meters above the reference point. Question 2 is quite similar. A red ball hit the wall outwards 4 meters, rebounding back 7 meters. So in terms of distance, it should be equal to 4 plus 7. Whereas for the displacement, it will be equal to plus 4 plus minus 7 equal to minus 3. When you see the minus sign, it implies that it is below the reference point. So can you understand the meaning of distance and displacement? The distance is total length. Displacement is based on the reference point to determine the length. Earlier examples, we only talk about a parallel path up and down. Now in example 3, you look at the red ball, it hit at the different angles and rebounds. Find the total distance and displacement. For total distance, it's very straightforward. It's 4 plus 2 equal to 6 meters. Whereas for the displacement, which is vectors, in these examples, we try to recommend a new method using the vectors diagram to determine the total displacement. Look at the diagrams using P to represent a red ball throwing upwards with the angle of 60 degrees, and using Q as a vectors to represent the ball rebounding 2 meters away from the wall. To draw vectors diagram, you need to learn how to write the vectors equation. We're using R to representing the total displacements, or we call resultant length. The vector equation is R equal to P plus Q. Can you observe there is the arrow on top of all the letters? It will help you to identify this is a vector's length. How to draw vectors diagram? Since you know it's P plus Q, we start with P. So we start with P with the angles that is shown on the diagrams, then follow with Q. When it closes, it must be start to the end, will give you the resultant. In order to draw, you must given a scale accordingly. Here we're using 1 cm versus 1 meter. So you can see the diagram that we've drawn. The results, you also can use a ruler to measure. Here I do not do the measurement because we are going to the next method. Some people do not like to draw. So in example 4, we will recommend a calculation method, which is using the xy coordinations to determine the x coordination and y coordination of the individual vectors. First, we write down the vectors equation R equal to P plus Q. After that, we resolve each vectors into x and y coordination as shown at the corners left-hand side. Before we start to calculate individual vectors values, we have to define the direction in x-axis and y-axis. Which one is positive, which one is negative. In this example, pointing to the right is positive, going upwards is positive. Hence, look at the table at the center of the slide. Px is equal to 4 cosine 60. Qx is equal to 2 cosine 60. Both of them are passed. That means they are showing that the arrow is pointing to the right. And for else is for y coordinations. We have Py equal to 4 sine 60. Qy equal to minus 2 sine 60 because it's pointing downwards. So in order to get the resultants, we add these two values for the x coordinations and y values of the coordination. Subsequently, we get Rx equal to plus 3, Ry equal to plus 1.732. Redetermines the diagram as shown at the right hand corners, and we will calculate the resultant length as well and to find out the angle. Here the total length is 3.46 meters, whereas for the angle is 30 degrees. Can you get it? This slide will show you how to do a graphical presentation for distance versus time or displacement versus time. Look at the diagram. N is standing at the reference 0 positions, and now N starts running from point 0 towards the right at a constant velocity 4 meters per hour along the horizontal path for 1.5 hours. After that, she makes a U-turn and runs slowly at a constant velocity of 3 meters per hour for 2.5 hours. Plot graphs to show distance versus time and displacement versus time. Before you plot the graph, you need to tabulate two tables as shown below. Once you completed the tables, you should be able to see the graph as shown in this slide. In the graph of distance versus time, you can see that there are two straight lines with different gradients because they have different velocity. But you know that this graph will not be able to go to the negative because distance is a scalar. Look at displacement versus time. Look at displacement versus time. You can see that there is one positive gradient straight line and negative gradient straight line. Positive gradients is n is walking towards the right. Negative is showing that n start to move towards the left. Ultimately, you see the negative gradient straight line fall below 0. That is mean n finally is standing at the left, which is 1.5 meters away from the reference. Finally, we want to conclude the meaning of positive or negative signs for vectors. 1 is increase or decrease of values. 2, it will show you the direction of movement. up or down, or left to right, or one direction or opposite direction. Thank you.